Hi all. Today I'm going to present the system design of URL Shortener. One of the most frequently asked interview questions in the product-based company. Applications like TinyURL and Bitly convert long URL into a short, easy to share links. Although the functionality looks simple, the system processes billions of redirect requests every day while maintaining a very low latency and high availability. So in this presentation, we'll understand the requirements, architecture, workflow, scaling techniques, and the interview concepts behind building a product-ready URL shortener system. By the end, you will understand not only how it works, but also how to explain it confidently during the interviews. Let's first understand what a URL shortener is. URL shortener converts a long web address into a short and unique URL. Internally, the system stores a mapping between the shortcode and the original URL. Whenever someone clicks the short link, the service quickly looks up the original URL and redirect the users. Popular example includes TinyURL, bit, bit.ly, and Twitter's t.co services. Companies uses URL shorteners not only to make links easier to share but also to track the user's clicks, generate analyticals, and to create QR codes and for the managing the market campaigns. The problem is popular interview because it covers the important concepts like caching, database, scalability, unique ID generation, and the distributed system. Before designing any system, we identify the requirements, right? The functional requirements include generating unique short URLs, redirecting the users correctly, and tracking the click analytics and supporting the link expiration. The non-functional requirements focus on performance. The system should provide 99.9% of availability because even a small downtime affects the millions of links. It should also handle millions of redirect requests every second while keeping the response time below 10 milliseconds. The three requirements help us to design a system that is scalable, scalable, and capable of supporting the internet scale traffic. Uh, Now let's understand the architecture. When a user creates a short URL, the request first reaches the load balancer, which distributes the traffic across the multiple application services. The application generates a unique short code and stores it in the database. Whenever someone clicks the short URL, the application first checks the ready cache because redirects the operation or most read request. If the data exists in cache, the original URL is returned immediately. Otherwise, the database is queried and the cache is updated. And the other user is reflected using the HTTP status code 301 or 302. This cache first architecture significantly improves the performance while reducing the database load. Let's see how the complete system works. First, the user submits a long URL. The server generates a unique numeric ID or using the auto increment or snowflake ID. Next, the ID is converted into a short alphanumeric code using base 62 encoding. The mapping between the short code and the original URL is stored permanently in the database. The shortened URL is then returned to the user. Later, whenever someone clicks that short link, the system checks the release cache first. If the URL is available, the system directs immediately. Otherwise, it retrieves the original URL from the database, updates the cache, and finally redirect the user. Now let's understand how the system handles a massive traffic. The load balancer distributes the request even across the multiple servers. The Redis cache store frequently accessed URL is in the memory, reducing the database access and improving the speed. The database replication separate write operations from read operation by using one primary database and the multiple read replicates. As the dataset grows, the database sharing distributes the data across multiple databases. Rate limiting prevent abuse and protect the service from excessive traffic. Finally, the continuous monitoring tracks latency, cache hit, ratio, and the error rates so engineers can quickly identify and resolve the performance issues. Finally, let's summarize the key interview points. Uh, Interviewers commonly ask how unique IDs are generated, why base 62 encoding is used, how the system handles the hundreds of millions of redirects, and how collisions are avoided, and how architecture scales to trillions of URLs. The important design decisions include using Redis cache for faster reads, consistent hashing for shading, choosing between HTTP 301 and 302, redirects the database replication, and the collision handling. You should also mention the practical challenges like cache, invalidation, replication lag, hotkeys, and abuse prevention. The most important interview tip is this: don't just describe the architecture, explain why each component is used, discuss the trade-off, and describe how the system handles the failure. That demonstrates the true system design thinking. So thank you for watching, and if you have any queries, you can put it in the chat box. Thank you all.